Hey guys, welcome to Pre-Calc, lesson 9.8, graphing trig functions with phase shifts. All right, day 8, horizontal or phase shift with both B and C values. Take a look at our general form equation right here. It's got all the parts that we are going to be graphing in this unit. A represents amplitude. You should already know that. B is our frequency, which is the number of cycles between 0 and 2 pi for these applications. C is the new one today. That's what's called a phase shift. We call it a phase shift with trig functions, but it's also known as a horizontal shift. And D from yesterday is a vertical shift. What we are going to do is we're going to put all of this into practice. One thing I want you to take note of, our B term has to be outside of the parentheses. So you'll notice in this first example, our B term is inside the parentheses. So what we need to do first is take this out. This is actually a GCF. It might not look like a GCF because this is a 2 and that's a pi, and it doesn't seem like they have anything in common. But remember, you can actually factor out whatever you want. We always call it a GCF, but it doesn't have to be. So if I want to take that out, what would go in the parentheses? Well, what would go in the parentheses is what you get when you divide both of these by a 2, because you take the 2 out. So this would just be x, which is what we want, and then this would be minus pi over 2. Now I can properly identify that phase shift. It's going to be right pi over 2, not right pi. Okay, that's why I have to take out the GCF. Now let's identify everything. Amplitude equals 1. Frequency, or your B term, is 2. Now you calculate the period, 2 pi over 2, so that's just pi. Our phase shift is right pi over 2. And our vertical shift is nothing, nada. So we don't even need that. Don't have a vertical shift. Before I set up my axes, what I want to do is make my thumbnail sketch. We have positive sign. So that's hill valley, if you remember. The period is pi. So one cycle of this will be pi. Now let's set up our axes. Here's my y-axis, x-axis here. And let's go out 4 blocks and make that pi. 1, 2, 3, 4. That's pi. So halfway is pi over 2. Between that and 0 is pi over 4, so we're going by fourths, which makes that 3/4 pi. I don't have a vertical shift, as we said, and the amplitude is just 1, so to make this easy, I'll just put a 1 up here a little bit so I can make this graph as big as I reasonably can. Now here's the challenging part. If I didn't have a phase shift, I would just have to transfer these points to this graph. So that's pretty easy. It would look like this. Put a point here, put a point there, put a point here. It would look like that. Okay, let me sketch that in. Concave down, followed by concave up. But what we are doing is we are moving it right pi over 2. So I have to take these points here and move them that way pi over 2. Well, it's kind of easy to visualize if I just do this. If I just drag this over pi over 2, it goes right there. So then you can probably see, what do I need to do next? Well, I need to fill in from here to 0. Now, it's harder to do that on your paper, obviously, but what I recommend doing is taking our starting point. So this will be the beginning of my hill, which is followed by a valley. And obviously this pattern continues. So once you get the first couple points, it's real easy to continue that pattern. So I'll take the beginning of my hill and I move it right pi over 2. So if I was creating this graph, all right, I obviously wouldn't do that, but I'd take that point, go right pi over 2. That's the beginning of the hill. So then I go up to the maximum and then back to your midline, and you could keep going. Well, I wouldn't necessarily have this part of it. I would be able to sketch this first part, and I like to sketch it back to the y-axis. So just follow this pattern, obviously. This pattern going back to the y-axis is going to do something like that. So if I'm going backwards from pi over 2, I go to the low point, back here. So this sketch is one cycle of that equation. So you might notice now the first thing that you recognize about this graph, yes, it has a phase shift. It's a sine graph that has a phase shift. But this shape should also look familiar to you guys. Hey, isn't that just a negative sine graph? It is. So what's kind of cool about a phase shift is it turns sine into one of our other functions, like a negative sine, or maybe it's a positive cosine, or maybe it's a negative cosine. So there's actually an infinite number of equations you can write for a trig function based on the phase shift. So I take a look at this, and if I didn't know it was a phase shift, I'd say, oh, this is just a negative sine. So if I had to write the equation, I would get y equals, it's a negative sine, amplitude is 1. The period is pi, so that means my frequency is 2, x. So it turns out this equation right here represents this, as does this one. So these two equations, I would say, are equivalent. So that's kind of a cool feature of phase shifts. Our next example is about as difficult as it gets. So you notice here we have everything. But before we start listing the pieces, we need to make sure we factor out the frequency. So I'm going to rewrite this as 2 cosine. I need to factor out a 1/2, and I have this plus 2 at the end. If I factor out a 1/2, basically we're dividing by 1/2, okay, which is kind of confusing. So think about division by 1/2 is the same as multiplying by 2. So I'd have x minus 2 pi in the parentheses. Now I'm going to use this equation to get all my information. All right, amplitude is 2. My frequency is 1/2. My period then is 2 pi divided by 1/2. Copy, change, flip. That gives me 4 pi. My phase shift is right 2 pi. My vertical shift is up 2. Got a lot of 2's here. Okay, so now before I set up my axes, let's make a quick thumbnail sketch. Without any transformations, just getting the period, a cosine graph looks like this. And for this particular application, the period is 4 pi, so that needs to be 4 pi right there. So I know one cycle is 4 pi units long. Okay, so let's set up our axes now. Y-axis, x-axis, and let's go out 4 blocks. 1, 2, 3, 4. That is one period, so that's 4 pi. Pretty easy to label. Half of that's 2 pi, half of that is pi, and then I've got 3 pi right here. My amplitude is 2, and I have a vertical shift up 2. 1, 2, 3, 4. So I have just enough room to do this. I actually probably should have made my axes a little bit lower, but anyway, I'll do this. Let's call that 1, 2, 3, 4. I'll have just enough room there. But like I said, in hindsight, I probably should have drawn this down towards the bottom. So what do I do now? I need to transfer these points to this grid, but I'm adjusting my midline. So I would probably do that first. My midline is going to be up 2. So here's my midline. Let's put that in. That's one of the more common mistakes that I make and that I see forgetting to do our vertical shift. Okay, so now let's talk about the phase shift. What are we doing to the graph? We're moving it right 2 pi. So I've got like this shape here that I'm moving this direction 2 pi. Probably the easiest way to visualize that again is to take your thumbnail sketch and say, okay, well, normally I start at the maximum. I have to move that maximum point right 2 pi. Okay, so let's see. Here's the maximum, right? My amplitude is 2, so up 1, up 2. There we go. Move that right 2 pi. So it goes right here. If you know this is the maximum point, this is why I like cosine. If that's the maximum, I have to go down in both directions. So this represents that. And to follow the pattern, next you go to your midline here, and then you go to your low point there. Going this direction, I would go to midline to low point. Okay, this is concave up, concave down, concave up. Let's do a couple checks. This is the amplitude. I count, that's 2, that matches, good. Period, that is 4 pi, 1 cycle. Matches that, perfect. Vertical shift, up 2, yes. This is the part that's a little bit harder. If I were to take a cosine, so that starts at the maximum, ends at the maximum, did I move it over 2 pi? So that's right 2 pi, and that matches, yes. Again, what we talked about in the last example, this is kind of cool because when I look at this shape, I don't think cosine, I think negative cosine. So if I had to write this equation, I might think it's a negative cosine. We said there's multiple equations you can write. I might be getting a little bit ahead of myself here, but I would think of this as y equals negative, my amplitude is 2, cosine. If my period is 4 pi, that means the frequency is 1/2 x, I still shifted it up 2, plus 2. You don't have to write this other equation yet. We'll get there tomorrow or at the next lesson. But it's kind of cool to note that this equation right here and this equation right here are equivalent. You put these both into your calculator in y1 and graph them on the same window, you get the exact same graph. Okay, let's move on to tangent. This one's a little bit more difficult. Tangent's always kind of its own animal to work with. So y equals negative tangent pi x. A couple things going on. Number one, we don't talk about amplitude when it comes to tangent. We talk about frequency to start. So frequency is pi. Notice there's no phase shift or anything with this one. So my period for tangent, and I should actually put a little asterisk by this because period is different. It's pi over b. So in this case, it's pi over pi, which is just 1. That'll make setting up your axes a little bit easier. After you get the period, you have to remember that we have vertical asymptotes when it comes to tangent. Vertical asymptotes are period divided by 2, plus or minus, because I like to get the first asymptote to the right of the y-axis and to the left. So in this case, that's going to be plus or minus 1/2. And note this. If it starts with a negative, there is a reflection in the x-axis. Now, I approach this one a little bit differently than with sine and cosine, and it doesn't really matter. You can sketch 2 cycles to the right, 2 cycles to the left, 1 positive, 1 negative. But I always, if I have a choice, I always like to put my y-axis in the middle for tangent, because I think it's easier to get the asymptote on the right and the asymptote on the left. And that's why I basically do this. All right, so we have to go right. I'll go 4 blocks. That will be 1/2. And let's go left and make that negative 1/2. And because I like to do 2 cycles with tangent, just for practice, I'll go 1 more here. That's a 1. And remember your scale, that's -1. So I like to start tangent with the vertical asymptotes, plus minus 1/2. Here, here, asymptotes. All right, let's get those in. Now, once you get the asymptotes, tangent's really kind of simple to work with, right? Remember what we said? Between the 2 asymptotes, it's 0. Between 0 and the right asymptote, it's at 1, which I haven't put in yet. And then between 0 and the left asymptote, it's at -1. So we kind of get this shape. However, we're reflecting the x-axis. So this is going to go down here, and that's going to go up there. It reverses the curve. It's now going to look like this. Okay, so again, I should put a 1 there and a -1 here. That's still 0. If I reflect on the x-axis, it stays 0. But this point gets reflected down here. Okay, and then this one would go here. We said we just reverse the curve. That is somewhat decent, I guess. Now, in this space is going to be the right side because this other asymptote will be over here. So I'm going to see that. So basically I need to take this and put it here. Okay, so that's a 0, and this would be at -1, and I'd only see that part of it in that window. Then I need to take this piece here and put that here. So that's 0, and between there is 1, and I'd see this. And again, I know it's a little bit hard to visualize, but this pattern just continues over and over and over again. Two more examples. Example 4, y equals 2 cosine pi over 2x minus pi minus 1. Again, the first thing we need to do is take out this GCF. All right, so what do we get? 2 cosine. Take out a pi over 2. You've got a group of parentheses. This will be x minus something minus 1. So what we're doing is we're dividing by pi over 2, which again is the same as multiplying by 2 over pi. So if I multiply by 2 over pi, those pi's cancel. I'm just left with a 2. So that's just going to be 2. Now that I've taken out that frequency, I can get all of my information. My amplitude for this graph is 2. My frequency is pi over 2. My period is going to be 2 pi divided by pi over 2. I always write that out. I don't try and do that in my head. And then we do copy, change, flip. So multiply by 2 over pi. Pi's cancel. 2 times 2 is 4. The period is going to be 4. Remember we said, if you've got a pi in your frequency, your period is not going to have a pi in it because it'll end up canceling with that. Let's do phase shift. Right 2. And a vertical shift, down 1. I'm talking about positive cosine. So my thumbnail sketch, positive cosine. What is the period? The period is 4. So now I can set up my axes, then we'll introduce our phase shift and our vertical shift. So for cosine and sine, I like to set up my y all the way on the left. Here's my x. I'm shifting down 1. So if I'm going down 1, let me actually move this up a little bit. Let's do that. Okay, so now midline. Actually, I should label my x and y first. Sorry. So go 4 blocks. 1, 2, 3, 4. Make that 4. So obviously 2 there, 1 there, 3 there. That's easy. Amplitude is only 2, and we're only going down 1. So maybe I'll do this. -1, -2, -3, and let's go up to +1. Our midline, this part of my thumbnail, is being shifted down 1. So let's sketch that in so we don't forget about it. Dashed line there. That's my new midline, down 1. So now, how does the phase shift work? Right 2. So I have to take this whole section and move it right 2. And again, it's kind of easy if I just think of one point. I'm just going to think of this maximum right here being shifted right 2. So I take my maximum, which is amplitude is 2, go up 2 from the midline right here, move it right 2. So this point here gets shifted to that point there. So now, if this represents our maximum and I want to go to the right, I head down. So I have to head down. All right, midline here, minimum there. So that's kind of easy to get. Midline here, minimum, which would be down 2. So what's that, -3? And then you've got this piece. That's concave down, followed by concave up. And I could continue it this way if I had more room, but if I just need one cycle, obviously I'll bring this back to the y-axis like so. Just follow the pattern. Midline here, minimum there. Concave down, concave up. All right, and there's one cycle of that equation. All right, our last one is a little bit crazy. Y equals -3 sine 2 pi over 3x minus 4 pi plus 2. So we got a whole lot of algebra going on here in the beginning, and then the rest should be pretty straightforward. I need to rewrite. -3 sine 2 pi over 3 times x minus something plus 2. So how do you get this? That's the biggest question. I'm taking out a 2 pi over 3. So you can think of it as dividing 2 pi over 3, but that's a pain. So think of it as multiplying by 3 over 2 pi, right? That's how that cancels. So if I multiply this by 3 over 2 pi, pi's cancel. 2 goes into 4 twice, and I'm left with 2 times 3. So that's just going to be 6. Okay, now I can get all my information. What is your amplitude? 3. What is your frequency? 2 pi over 3, which seems like a pain until we do this. Period equals 2 pi over frequency, 2 pi over 3. Copy, change, flip, times 3 over 2 pi. Okay, 2 pi's cancel. Works out great. So that's just 3. One thing you might pick up on when our frequency has 2 pi in the numerator, whatever that denominator ends up being is the period because the 2 pi's cancel. All right, so what else we got going on here? Phase shift. Right 6. And vertical shift, up 2. Quick thumbnail sketch. Notice, we haven't seen one of these in a little while, but it's negative sign. Well, normal sign is hill, valley. Negative sign is valley, hill, because it's a reflection in the x. And we said the period is 3. So one cycle of that's going to be 3. Okay, so let's set up our axes. Then we'll talk about phase shift and vertical shift. Vertical shift up 2. So if I'm moving up 2, let's put our x-axis down a little bit lower. How about here? Let's go out 4 blocks. 1, 2, 3, and 4. And that is going to be the period, 3. Well, this isn't so nice. If that's 3, this is 3 over 2, right? 3 halves, half of 3. Half of 3 halves is 3/4. Remember, you can just keep doubling that denominator as you get smaller and smaller and divide by 2. So if this is 3/4, think of this as 6/4, and then think of this as 9/4. And then we've got 3. Now, it's probably not necessary that you label these if it gets a little confusing, but just make sure you put the tick marks for those there because we have to take the period and divide it by 4. And if you just want to label the half and the full period, that's okay. But again, just make sure you put those tick marks there. Okay, amplitude is 3, and I'm going up 2, so I need a scale that'll allow me quick counting here. I think I'm just going to have to go by ones. So that's going to be 2, that's going to be 4, that'll be 6, and this will be -2. All right, let's get our midline here. Midline, up 2. Okay, up 2, midline. Here we go. Next, our phase shift. Right 6. Holy cow, right 6? I don't even see 6 on my x-axis. So let's think about it this way. That point right there needs to go right 6. Well, that goes beyond the period. So let's kind of work backwards. This whole thing is 3, and you got to move that whole thing right 6. Well, if you think about it, if I move this right 6, what's happening here? This repeats, right? And then that would be 6. Wait a minute. If this moves over here, then look what happens. It's the same thing. It's still what we say in phase. So even though I'm moving this right 6, that's just double this, which means the graph's going to look exactly the same. That's what's kind of cool about this one. So it'll start at the midline. It'll go down to the minimum. So let's see, my amplitude was 3. So 2, that'd go down to -1 right here. Back to your midline. Then up 3, so to 5, which is here. Back to your midline. Concave up. Concave down. So we say that this original and this are in phase, because it doesn't matter if I move this over. It's like saying move it over 3. Well, if I move it over 3, it's going to be the exact same graph. I can move it over 6. I can move it over 9. If that is a multiple of this, it's going to be in phase. The phase is not going to be changed. So that might be a little above and beyond what you're likely to see on an exam, but it's kind of a cool example to go over nonetheless. All right, guys, that concludes day 8. Thanks a lot for watching. And as usual, if you have any questions, don't hesitate to reach out. We'll see you in class soon.